Okay, hello everybody. This is Damalash Ibrahim, and in the previous version of this video, we have just tried to see different user interface of Civil 3D. So today we are going to see about this Civil 3D software. How can we just operate on this software, starting from importing surveying data and then creating a surface. So after creating a surface, there should have been a boundary, so there should have also been creating a boundary. We'll see this, and we'll also see the horizontal alignment design. So after importing surveying data and after specifying the boundary and the surface model, you can just design the horizontal alignment or the horizontal section of the roadway geometry. So and after designing the horizontal geometry of the road, there should have been also the profile of the natural ground level. So this Civil 3D will be able to generate this profile, and after generating the OGL profile, we will be able to design the vertical alignment or the vertical section of the road geometry. So we will see this in detail in this video. Let's start by now importing that surveying data. So the previous section, as we have seen, here is a ribbon tab. So from insert tab of ribbon, this is in the insert tab of ribbon, this is the home tab of ribbon, and this is the insert tab of the ribbon. So from this insert tab of ribbon, go to point from file, and then from this the importing surveying data dialog box will come like here. So click on the plus sign, and then go to your surveying data. So the surveying data mostly prepared in Excel format, CSV model method. So go to your surveying data. For example, my surveying data is located on the desktop, so go to desktop. Here is desktop, then from desktop there is a folder. So by double clicking on your surveying data, you can import the surveying data. After importing it, I have to select here the file format. There is different file format. For example, let us see what our surveying file format seems like by opening from the original file from desktop, and then go to GC2000 and checking, and this is the first folder. So opening this file is my original file actually. So here in this Excel, it shows what format, the file is available. So here is the first column, and there is generally 1, 2, 3, 4, 5 columns. So the first column describes the numbering, and this is easting, northing, and this is the easting, and this is the elevation, and this is a description for each point. So in this format the file is just available in this format, which means numbering, northing, easting, elevation, description. So based on this file format, I will specify here in the Civil 3D. So here is easting, northing, elevation. It is not. It is actually contain only 3 columns, while in our case the file contains 6 columns. So point number easting is Z. This is actually our file format. Here also points numbering easting Z description. Yeah, this one. So this one is our file format. So by clicking on OK after specifying my file format, click on OK, the file will come like here. Actually I open this file. In opening this file it may not be displayed the Civil 3D at the same time, so I have to import again this file from point file. So go to the previous section. So here this is, so this one, specify the file format and OK, change the file will come. Just click on OK. So there is no display of there is no any display of my points. So in order to display my point, click make a zoom extent. So the corridor file will come like here. So this is my surveying data, which is a topography data, corridor data. So based on this corridor data, I can prepare the design of the road. So let's start. Let's start it. The first stage is importing the surveying data. After importing this surveying data, the next will be creating a surface. So from the prospector menu, as we have seen in the previous section of this video, this is a this is a tool space. The tool space is generally divided into 3. Prospector is here, and settings, survey, and toolbox. So now I'm going to work on prospector. So click on the prospector tab of this Civil 3D. So from prospector, right click on the surface, and then create a new surface. Here is create a new surface. So type the name of your surface here. So my surface is just the natural ground level. So there is a description here if I want to give any description regarding to the surface, and here is a counter style. So make it actually within 5 meters. Which is the most commonly widely used, and then click on OK. Here I can also modify the layer, so the setting from this layer. So the color and the label, etc. So click on OK. So here I have just created the surface, but the nothing is done from the user interface. So in order to see the surface, go to your surface by expanding this surface, I can find my surface, which is NGL here. So expand again this, and then from definition go to point group. Then from point group add point group. So I want to add all points should be included in this surface. So then after selecting all points, click on OK, and then the surface triangulation is just come like here. Actually there is no need of triangulation here in the Civil 3D. Automatically it will calculate the contour, so the contour come like here, but I don't want any contour out of my corridor data. For example, here is out of my corridor data, so I don't want a contour around here. So in order to limit this one, make it or define a boundary or create a boundary. I have to create a boundary. So to create a boundary, then go to surface property, from surface, then right click on your surface name, which is NGL. Then after right clicking, surface property will come, and click on surface property. And then after getting this surface property dialog box, go to definition, then go to build, and then from build I have to limit the maximum triangle length. So the maximum triangle length is just set to no, so I have to change it to yes. I want maximum triangle length, and the value I have to set the value. So the value I want maybe 200 meter maximum triangle length. So after setting this, clicking on apply, so the Civil 3D just ask me to whether or not I am willing to the rebuild or change in this drawing. So I want to rebuild this, and click on rebuild the surface. So the surface will be rebuilt automatically in this way. So here, as you can see, the surface is just created on near to or on the way where my corridor data is located. So out of my corridor data, there is no any surface created. So I want this actually. So the next step after creating this boundary and creating the surface will be horizontal element design or horizontal geometry design. So in order to design the horizontal geometry, from the property, go to information, and then make surface style border only. Go to property, again open this surface property, then go to this information, then make the surface style border only, and then click on apply, and then from point group, make this all points to be disappeared from this user interface by changing this point style to none. So apply, then OK. So there is now points displayed now. So I want to display the center line. So from this point group, I will have to create a new point group, which includes the center line. Actually, as you can see from my original surveying data from here, there is a description. So under the description there is different description here. So CL here, CL stands for center line. So I want to display the center line only. So in order to display the center line, go to point group here, point group, right click on point group, then new, click on new, and then this point group is set to be a name CL, center line. And then from this point group, the point group I need to create is allow data to include with raw description matching CL. So here tick with raw data description matching, and then click your description under the required point groups. So apply and then okay. So here, as you can see, the center line data only come like here. After displaying the center line data, I can place, or I can draw the proposed roadway alignment. So in order to do this, go to alignment from home tab of ribbon. This is the insert tab. So from home tab of ribbon, go to alignment, then alignment creation tool. Here alignment, there is a drop down, then alignment creation tool is here. Then open this alignment creation tool. Then after opening this, I can give a name for my alignment. Actually, I want to be default name. Also, I can specify the site if there are different sites. So the alignment style is the proposed alignment actually. So then click on OK. Then the alignment creation tool dialog box will be like come like here. So here in the first drop down, there is a alignment creation tool selection both. So the first is tangent with no curve, the second is tangent with curve, so curve and spiral setting. So I want to draw my alignment by tangent and curve, so click on this and then go to the first or the beginning of your project and start by drawing your alignment along your proposed roadway alignment. So here I may have okay, let me skip it and start it again. So start from the initial point. So since PI is out of the center line, so I make it the PI will be out of my alignment. Here also there is a PI which will be out of my alignment, and then drawing in this manner. in order to get a desired effect. I have to zoom as required. So after finishing, click on enter, and then the horizontal alignment or the geometry of the road will be automatically designed here, so I can have a clear view of my alignment by making this point to not be displayed, and then can have only the view of my alignment here is my alignment only. So this every parameter of this geometry is just put and designed based on a design standard. Some design standard was on this software, but I don't know what is its design standard, but every country has its own design standard in order to suit the design for local condition. So in our country, Ethiopia also have its own design standard, so I have to calibrate the software in order to fit with our country. So in order to do that, I have to select this. First I have to prepare my design standard in its format that the Civil 3D can accept. So I have that file. So after selecting the alignment, here I can find alignment property, then go to alignment property and then open this alignment property. As I opened this, there is design criteria. So use criteria based design. So now I'm going to make the software to use a design criteria based. So I have to give what design criteria it have to use. So from here I can import here is era design criteria. Actually this is the design criteria which is prepared on Ethiopian Road Authority design standard. So based on this I have to calibrate the software, then open this, and then automatically here era Emacs come, but I want to use era 8% superelevation. I want to use maximum superelevation 8%, so make it this, and then after doing this click on apply. Before that I have to set here the design speed. So far when we design a roadway section which will just pass within a different topography, at this section, at this different topography of the road section, there may be a difference in design speed. So in order to make that, or in order to difference, or in order to provide this different design speed at a different place, here is a methodology I can give design speed for different station. So for example, here I may have 40 kilometers per hour for station starting from 0 plus 0 0, and then I may have another station after 0 plus or after 5 kilometers, maybe let me make it 2 plus 0 0. After 2 kilometers they may have a different design speed, so I can make this change here from here. So 40 and then maybe 60. So by doing this actually this is 200. By doing like this, and then importing every different design speed here within their respective station, after finishing apply, and then okay, and then now after completing this, the software automatically will update and will design or will prepare the roadway alignment based on the given design criteria. So this is just based on ERA design manual. It was just changed to ERA design manual. So here if I want to correct or change any PI point, I can make a change from here by clicking on here. I can change the position of any PI. So by doing like this, I can rearrange, or I can correct my horizontal alignment like this. Always doing this, I can just prepare my horizontal alignment. So after doing this, the horizontal alignment here, there is a remaining thing actually, because I don't still now I didn't prepare, or I didn't design the super elevation of this road section. So I have to do this by going to super elevation calculator by clicking here on the alignment. Okay, just click on the alignment and then go to super elevation here, super elevation, and super elevation calculate already super elevation. Click on this, and super elevation task is just to change the super the existing super elevation zone. Then I have to click on OK, yeah, this, and then the super elevation calculator, or the calculate super elevation dialog box will come like here. So in this case I have to set the roadway type here, whether or not it is undivided crown or undivided planar, so mostly the most roadway were just in this form, undivided ground. So then there is a divided ground, and if there is a median, so based on this manner I have to set this. There is a lane, number of lane I have to set a number of lane, so mostly the number of lane will be just two number of lane, number of lane left and right. So actually one lane in the right and one lane in the left will be provided. So normal lane widths, I have to give this value. Normal lane widths will be mostly 3.405, and then crown normal lane slope is 2%. Usually it is customary, and then go to shoulder control. So normal shoulder, how much it will be, 1.5. actually it is obvious. The low side under this low side, make a low side to match lane slope, and then high side and default match lane slope, and then go to select super elevation, maximum super elevation I may have here. There is a design criteria input format here. I can input from here the criteria, so I have just previously inputted, and then here I want to use maximum elevation of 8%, so I have to change it from this 4 to 8, and then transition lane length table should be 2 lane, and here actually attainment method I can use Ashto method, since the Ashto method is almost similar with that of the era, since this era is just most feature of this era manual is just copied and modified from Ashto by making it too suitable with our country. Here attainment method is here, so have it, and then after this tick automatically resolve overlap, apply curve that doesn't require. Then I have just finished working on this superelevation, so click on finish. So after clicking on the finish, there maybe the panorama window will come that informing me that the different forms, so the designed standards for the design value will come here, so leave it now. Actually there is some problem, I think, so I can fix this from here. And after doing this, now I'm going to give the offset for this alignment. The alignment is just prepared only the center line of the road. So There should have been the right side in the left side border. I have to provide that border by offsetting this center line. So select alignment in order to do this. Select alignment, and then from this alignment open offset alignment. Actually from home tab of ribbon can find it, alignment, then from alignment drop down box open offset alignment, there is offset alignment, so create offset alignment here. So the offset alignment dialog box will come like here. Then from here offset is just number of offset on the left one, on the right one, so I have to provide this, and but the offset lengths or the lane lengths, that means this is 3.5 actually, so 3.5 on the right and 3.5 on the left. So after providing this offset, and then make or I may have different in order to give different view for this alignment, I can fix it from the layer property. So after doing this, click on OK, and then click OK. The offsets were just displayed here. So here are the offset. So this offset is 3.5 meter far from the center line. So after